Hi everybody, this is our final project presentation for Data 620. I'm going to go through this really quick because this is actually my second go around. My first video was like 28 minutes long and that's just way too much. So excuse me for going really fast, but I don't want you to have to watch a 28-minute video. So we chose a recipe data set, had two files in it. We chose to only work with one of those files because there was some confusion about what the other one really represented. So we just went with the file that had one recipe per line. It included the type of cuisine and one ingredient per column for all the ingredients in the recipe. So we imported our libraries and loaded the CSV into a pandas data frame. Then we used that data frame to create a corpus from the data so that we could do text analysis. Not sure why that link is so huge, but we used a function we found on Stack Overflow to turn that into a corpus. Basically, it had to we had to create a text file for each line in the data frame first, and then read those back in to NLTK corpus reader. So we can see that here. Then we looked at the distribution of recipes and found that there was a huge overrepresentation of Northern American cuisine, which factored into how we did our analysis because we wanted to try to compensate for that. Distribution of the number of ingredients overall. Overall, most recipes had between 5 and 10 ingredients, but again, that's influenced by the overrepresentation of North American cuisine. So then we looked at the average number by cuisine. Southeast Asian had the highest average at 11.31 ingredients per recipe, and Northern European with the lowest at 6.82 ingredients per recipe. We plotted out the distribution by each of the number of ingredients by each cuisine, and you can see those differences there. Then we looked at the most common ingredients overall in the whole data set. Eggs, wheat, and butter came in the top 3, but again, that's highly influenced by Northern American recipes. We had a number of ingredients that only showed up once or twice. So later on, we kind of filtered those out because we had an insane number of ingredients. I'm trying to remember how. 381 unique ingredients. So we did our text analysis, made sure our corpus agreed with the numbers that we got from pandas above, and we were off by 2, which was a little weird, but considering that was out of 464,000 ingredients, we didn't think 2 was going to really affect our analysis, so we decided not to spend time on that. So then we looked at how many ingredients represented half of all the ingredients in all the recipes, and there were 22 ingredients that represented half of all of them. You can see the list there. We plotted that out so you could see it visually too, and plotted out the top 50. So you can see a huge drop off though after the first few, which are eggs, wheat, butter, onion, and garlic. So then we did the same thing by each cuisine, and you can see the top ingredient is different for different cuisines, although butter is the top ingredient for quite a few of them, for Eastern European, North American, North European, and Western European. So then we looked at the top 5 for each cuisine. And again, you can see very different kind of flavor profiles with most of the European and the North American relying heavily on butter, eggs, wheat, and cream or milk, and Latin American and other cuisines having more savory, cayenne, onion, garlic kind of profiles. Then we calculated the number of times the ingredients showed up as a percent of the total recipes for each cuisine to try to compensate for that overrepresentation of North American cuisine. We did ingredient pairings, looking at every possible pair of ingredients that was in the data set, and then counting the number of times those showed up in each cuisine as a percent again, so that we could compensate for the excessive number of North American recipes. So here we have it sorted by the counts, which, like I said, not the best way. So then we did the same thing by percent, and then you can see some other cuisines showing up in our top list there. There's our top 3 pairings by each cuisine. So you can see the different profiles there. Then we did a network and text analysis of each individual cuisine. So we did a graph as well as a text analysis. And you can really, if you look at them and compare them, you can really see the different flavor profiles showing up. African had a lot of spices. We had East Asian had, cayenne, soy sauce, scallions, and sesame oil as like top ingredients. And again, just in the interest of time, I'm gonna kind of skip over the text analyses. But if you look at these graphs, you can see a big difference. Some of them drop off more precipitously after the first few ingredients and flatten out early on, whereas some like this one are more slowly sloping down. So indicating that there's more variety overall in the ingredients, not so heavily reliant on just a few. Eastern European is actually a good example of one that is heavily reliant on just a few. So you can see that in the thick edges connecting the butter, eggs, and wheat. And then you can see that again in the way this graph drops off at the bottom. Latin American cuisine, tomato, onion, garlic, cayenne are your top 4. And you can see that again in the graph here. Middle Eastern, wheat, garlic, eggs, olive oil. Olive oil is really the big one for Middle Eastern. Again, North American, eggs, wheat, and butter. You can see that. Let's see. I'm going to kind of just go quickly through these. Northern European was the one that was most heavily influenced by butter, eggs, and wheat. I mean, these super thick connections showing that they show up in a large portion of the recipes. So they're really heavily reliant on those 3, which again you can see in this graph at the bottom, which just drops way down after those 3. Sorry, which one is this? South Asian. Here we got coriander. This is the only one that includes yogurt, assuming that's the influence of Indian cooking there. And all the curries that use yogurt and cumin and garlic and ginger, turmeric. That's what we're seeing there. Again, not so reliant on just a few ingredients though, really showing a lot more variety in overall. Southeast Asian was interesting too, because no really thick heavy edges between the ingredients in this one, so there's more variety, I guess. And here, let's see, what did we have here? Fish. Yeah, fish was the big one in here. which now, of course, why am I, there it is, which is connected to almost everything else. The only one that maybe has more connections is garlic. Right, and then I think we got two more. Southern European, olive oil and garlic, huge, and tomato, which makes sense. This is your Italian, mozzarella cheese, Parmesan is in there also. And then the last one, Western European, isn't one of the others that's heavily reliant on wheat, eggs, and butter. So then we did a bipartite analysis. So you can start to see the kind of similarities and differences in here. We used the island method to kind of keep raising the water level, and ended up with the third graph really showing the most significant ingredients in each cuisine and the connections between different cuisines. Here's your European and North American, all heavily reliant on the eggs, wheat, and butter. The Southeast Asian with fish. South Asian with your coriander, turmeric, and ginger. East Asian, sesame oil, rice, scallion, and soy sauce. So it's really, you can really clearly see the different flavor profiles in that graph. And you can see here the top few ingredients for each cuisine in that graph. So in conclusion, we basically saw what we expected, lots of similarities, but also lots of differences. We saw that the cuisines of cultures that shared a continent seem to be more similar to each other than they were to other cuisines. One very strange, noticeable omission from the data set, though, was sugar. I was really surprised not to see sugar anywhere in here, considering all the wheat, eggs, and butter and cream, which indicated there might be a lot of baking going on, possibly desserts. So that really needs a little more investigation to figure out if that was purposely excluded from the data set or why that's missing, if it's really not that much dessert baking going on. So that's it. Thanks for watching.